A train consists of several tracker vehicles that can move together to carry cargo or passengers from one place to another through a specific route. Rail transport can be categorized into different market segments based on the nature of the goods transported for industrial product, agriculture commodities, consumer goods, and intermodal transport. High-quality infrastructure is essential for efficient and safe movement of rail transport. It includes rail tracks, cargo terminal, signaling system, and easy of maintenance.
Next, I will be explaining about the railway theory. Wheel trains were the most basic kind of transportation available at the time for both passengers and cargo. The road is still covered in dust. Rain turned the road into a valley, and the tracks of passing wheels were left on the earth. The dam straightens after drying, and a few wheel trains are able to cross it. It turns out that by following the buckle, the wheel may run more simply and directionally, allowing the driver to easily regulate the direction of the wheels and change the train speed. There are essentially two components to the construction of the train railway. The rail track structure is at the top, while the track foundation is at the bottom. In order for the train networks to move swiftly, safely, and pleasantly, the train railroad must hold strong when it is passed by the train network. The idea behind this track foundation design is to maintain track stability during the passing of the train network, allowing the railway lines to stay in their original location, avoid swinging or ambling into the earth, and be able to endure the weight of the passing the train network. Now, let us talk about the challenging of railway construction. First, for going underground. Construction methods can be disruptive depending on the needs of a project and its location. The construction of underground metro systems helps preserve quality space above the ground, particularly in urban areas. However, limitations on urban space means that deep excavations for underground metro stations often approach existing structures such as buildings, utilities, and other underground facilities. Despite the considerable effort that goes into their design, many urban metro projects still encounter problems. Particular difficulties arise when conducting deep excavations in densely populated metropolitan areas, chief among them being the possible effects of induced ground and structural movement on nearby structures, along with difficulties with site entry and egress, shoring, underpinning, operational change, dust, noise, vibrations, and traffic congestion. They can also be an annoyance to the neighborhood. Early involvement of important stakeholders and the early detection and settlement of crucial issues that could negatively impact the community are essential to resolving these problems. Next is tunneling. In most situations, tunneling is the least disruptive type of construction. There is very little disruption to the urban environment aside from the locations where the tunnel boring machine, which is called by TBM, if applicable, must be inserted, and the locations are required for the removal of material excavated. However, a client's choice of tunneling technique may change based on the area and circumstances around the project. Choosing the best approach for the job will maximize savings and reduce negative effects. TBM is used to dig circular cross-section tunnels through different types of rock and soil. These devices are capable of boring through sand and even hard rock. TBMs can be challenging to transport and are costly to build. The relative cost of a TBM per kilometer in comparison to drill and blast techniques decrease with tunnel length. This is due to the fact that provided TBMs function properly, tunneling using them is far more efficient and has shorter completion times. The next challenge is cut and cover. Subsurface. Shallow tunnels are frequently built using the cut and cover techniques, which involves digging a trench at a shallow depth, cutting it, and then backfilling it. Rapid transit tunnels are often built using the cut and cover technique at a depth of at least 80 meters. This technique may be more cost-effective and practicable than subterranean tunneling at a depth of 10 to 40 meters. Nevertheless, this approach presents notable drawbacks, including extended building times, the need for construction allowance, and elevate surface deformation. Additionally, its travel is restricted to areas with open space above, including roads and greenfield sites, as it is unable to travel beneath buildings and other structures. Lastly is drill and blast. The drill and blast method has been used to remove rocks with varying strengths, such as quartz, basalt, gneiss, and granite, as well as weak rocks like chalk, clay, and marl. It is appropriate for usage in non-circular cross sections and relatively shorter tunnels when a TBM is deemed unsuitable. The vibrations and shock waves from the blasting process are the primary disadvantage of the drill and blast approach. Because of this, it is not a popular option in densely populated urban areas. The additional drawbacks of the drill and blast methods are high noise levels, fumes, dust, and flying debris. For the aspect of safety, it is necessary to guarantee that the railway infrastructure will protect the environment, workers, and passengers. This includes adhering to safety standards and laws, as well as doing routine maintenance, updates, and inspections. First, track maintenance and inspections on a regular basis to find and fix safety issues quickly. Second, following stringent safety guidelines and requirements, including as those pertaining to electrical safety, signaling, and track geometry. Third, track foundations can be stabilized and strengthened by using geopolymer injection, which lowers the possibility of track failures and improves overall safety.
Hi, my name is Nur Hasmiza Azmira. I will continue to explain about the risk and mitigation for proposed Trans-Borneo Railway project. For the introduction, the purpose of Trans-Borneo Railway project represents a transformative endeavor aimed at enhancing the transportation connectivity and promoting the economic development across the Borneo. As one of the largest infrastructure projects in the region, the railway holds the promise to facilitate the movement of goods and people, unlocking the new trade of opportunities and fostering regional integration. However, the Trans-Borneo Railway project still would likely face several potential risks and challenges, as shown in the pie chart. First one is regulatory hurdles. Second, land acquisition issues. Third one is geopolitical factors. Next, environmental factors. And the last one is infrastructure challenges. For the first category, which is the regulatory hurdles, the identified potential risk for this category of risk is cross-border complexities. Obtaining and getting agreement amongst Malaysia, Indonesia, and Brunei would be a major regulatory obstacle to facilitate the building and operation of the railway across international boundaries. Second, national regulatory framework. Regarding railway construction, operation, safety standard, environmental protection, land acquisition, and other areas of infrastructure development, each nation would have its own set of law, regulation, and administrative procedure. So it will be crucial to abide and receive clearance from various national regulatory framework. For the third one of identify potential risk is public consultation and stakeholder engagement requirement. Risk of facing opposition or delay due to inadequate stakeholder engagement, lack of community consultation, or failure to address public concern and expectations. For the mitigation measure for this potential risk is first, early regulatory assessment. We can perform an in-depth of review of the requirement and a regulatory framework in each of the project participating countries. Second, engagement with regulatory authorities. We can create the proactive channels of communication and interact with the appropriate regulatory bodies in each country to handle any potential issue or obstacle and get clarification on the regulation requirement. So it will be smoother approval and regulatory procedure can be facilitated by cultivating good ties with regulator. The third one is legal expertise and advisory support. We can hire the legal professional and advisor with experience in administrative law, infrastructure development, and regulatory compliance to assist in negotiate complicated regulatory environment, understand the law, and offer the strategic advice on risk reduction and compliance plan. Second category of risk is land acquisition issues. For the identified potential risk for this category risk is first, land ownership dispute. The possibility of disagreement about ownership, water, or competing property claim could cause the delay in the land acquisition procedure and perhaps give rise to legal issue. Second, resistance from affected communities. Risk of resistance or opposition from local communities, indigenous group or landowner affected by the railway project, leading to protests, blockades or legal challenge. Third one is a compensation dispute. Risk of disagreement regarding compensation amounts, method of valuation or sufficiency of benefit granted to landowner or impacted community for the acquisition and relocation of land. For the mitigation measure for this category of risk is first one is engage with stakeholder and local community. Is to verify the land ownership by conducting exhaustive land title search and survey. Second one is a develop community development program. We can implement open and inclusive consultation process to engage with the affected communities. The third one is to provide clear information and on compensation entitlement. So we can create the equitable and open compensation policies and procedure on market value assessment, replacement, cost principle, or compensation standard. Next category risk is geopolitical factors. The identified or potential risk for this category of risk is cross-border tensions, risk of political tension or disputes among the countries. Second, national sovereignty concern, which means is a risk of sovereignty issue or territorial disputes. And third one is regulatory uncertainty, risk of changes in government policies, regulation or legal framework. The mitigation measure for this identified potential risk is first one, we can build connection with international organization, monitor on geopolitical development and take part in diplomatic. Second one is respect on national sovereignty and territorial integrity. We can assure adherence to international law, treaties and agreements that regulate infrastructure projects that cross international border. Third one, we can keep informed on any changes in regulatory items to comprehend prospective regulatory changes and their implication for the project. Other than that, the next category of risk is environmental factors. The identified potential risk for this category risk is habitat destruction and biodiversity loss, which may risk of habitat loss and fragmentation brought on by railway construction. Second, the potential risk is deforestation and land degradations. It's meant by clearing large areas of forested land leading to deforestation and subsequent land degradations. And the third risk is climate change impacts. Railway project may contribute to greenhouse gas emissions through construction activities. The mitigation measure for this potential hazard is first one, we can conduct the environmental impact assessment (EIA) to minimize the habitat destruction and mitigate impact on biodiversity. Second, we can do reforestation and afforestation to mitigate the impact of deforestation and land degradations. Third one, we can using renewable energy sources for the railway project to reduce greenhouse gas emissions and enhance the climate resilience. Last category of risk is infrastructure challenges. The identified potential risk for this category risk is first, terrain and geological challenge. Borneo diverse terrain including mountains, dense forests and rivers presents engineering challenge. Second, infrastructure connectivity and integration require careful planning and coordination on integrating the railway with existing transportation infrastructure. Mitigation measures for this identified potential risk is first one, we can conduct a detailed geotechnical survey to understand the terrain characteristic and identify the potential hazard. And we also can use appropriate engineering technique and technologies. Next, we can conduct feasibility studies to develop interoperable infrastructure design and standard to facilitate the seamless integration with roads and airports. That's all about the risk and mitigation for proposed Trans-Borneo Railway project.
For conclusion, this research is about to analyze the project of Trans-Borneo Railway linking Sabah, Sarawak, Brunei and Indonesian Kalimantan. This project will be impactful to enhance people-to-people connectivity and economically. It will facilitate trade, promote growth of industries at the border area and boost tourism in the Borneo region. It is a cross-border project which involves a long railway network. The priority at the moment is focused more on reviving the existing railway network, especially connecting the track line. However, the Trans-Borneo Railway project is currently just a proposal, and this year the government will implement a feasibility study.
The Ministry of Transport (MOT) has yet to finalize the tender document, and the tender for the feasibility study has not yet been offered. They expect the feasibility study to take 9 months. Then only we will know if the project could be implemented or not in terms of the commercial, technical, and other aspects. And for recommendation, the Trans-Borneo Railway project contains the factor of local acceptance and rejection. The first perspective on politics, the Trans-Borneo Railway is to reach its political goal, and other side is this project also had a good outcome for improving infrastructure. With this development, all the area could easily connect, and the government could provide adequate services to the city. For economy, this project is seen as capable of generating rapid economic development and allow local contractors to expand their business. The last perspective on technology, this large scale provides a new experience for local construction companies and give opportunity to local companies to receive technology transfer indirectly. Local companies can also learn something new, such as business management and planning that involve large-scale projects. Thank you.